Okay, my dear students, so welcome back. In the previous video, we discussed about the Fourier series of odd functions, right? Today, we will start our discussion with Fourier series of even functions. What are even functions? Even functions are the functions defined on some interval minus p to p such that if I replace x by minus x, I get the same function fx. Or precisely, you can say that a function defined on the interval minus p to plus p will be called an even function if fx and f of minus x both are same. And in the previous video, we wrote all the formulas for Fourier series. We wrote the formula of a naught, an, as well as bn. Okay, so let us not repeat it in this video. And one more thing which will be important for us in this video will be that for even functions, when you are finding the Fourier series, bn will become 0. Okay, so no need to calculate bn. You can directly write that bn will be equal to 0. What you need to calculate? You need to calculate only a naught and an. These two only we have to calculate. Okay, so this is our preliminary discussion. Now let us take a question and let us solve it. So question is, let us take a function fx is equal to x square, and let us say it is defined from minus pi to plus pi, and the question is that find the Fourier series. Let us start our solution. Now, this function is very familiar to us. Fx is equal to x square defined on the function, defined on the interval minus pi to plus pi, which is of course an interval of the type minus p to plus p, right? And if we say that what about f of minus x, so this will be f of minus x, means this will become minus x whole square, which will be same as x square. So you have seen that fx and f of minus x both are equal. It means that this my function is an even function. And when we have an even function, in this case, bn will become equal to 0. So we need to calculate a naught and an. So in all the formulas, we will need L, which we define as b minus a divided by 2, where b is the endpoint of the interval. So here it is pi, right? Minus A. A is the initial point of the interval, that is minus pi divided by 2. So this will give us 2 pi divided by 2, that becomes pi, right? So L value also we have calculated. Now let us find A naught. What is the formula? 1 divided by L, that is pi. So 1 over pi. Integral from A to B, that is the interval is minus pi to plus pi, of fx. What is my function? My function is x square. So x square dx. So this will give us 1 over pi x power 2, integral will be x power 3 over 3, from minus pi to plus pi. This constant 3 you can shift outside your bracket. So this will become 1 over 3 pi, and inside the bracket you have x power 3 with a minus pi to pi. So this will give you 1 over 3 pi. So when you put x equal to pi, you will get pi power 3, minus when you put x equal to minus pi, you will get minus pi whole power 3, which is same as minus pi power 3, right? Or you can simply say that this will be equal to pi power 3 minus minus will become plus. So pi power 3 plus pi power 3. So that will become 2 pi power 3. And outside the bracket we have divided by 3 pi. So this gives us that 2 pi square over 3, right? 1 pi will get cancelled. So this is our first value, which is A naught. Okay. Now let us start with AN. AN. Let's write the formula first. 1 over L, that is pi, integral minus pi to pi fx, that is x square, multiplied by cosine n pi x divided by L, that is again pi dx. And you can see that this pi will get cancelled with this pi. So we have actually x square cosine nx. And as I told in the previous lecture also, in the previous video also, that you can use any method whichever you like. This is actually integration by parts. So people have their different ways of doing integration by parts, so it's up to you whichever way you want to do it. Okay. And because here one of the functions is a polynomial function, that is x square, so we can use this shortcut technique also, which we discussed in the previous video also. If you don't like this, you can use your own technique, no problem. Okay, so x square, we will find the derivative, that will become 2x. And cosine n pi, sorry, cosine nx, this we have to find the integral. So integral of cosine nx will become sine nx divided by n. Okay. And then derivative of 2x will become 2, and integration of sine nx by n will become minus cosine nx divided by n, and one more n is already present, so this becomes n square. Then derivative of 2 will give us 0. So this is our point where we will stop. And this minus cosine nx by n square, the integration will become minus integration of cosine nx will be sine nx divided by n, and n square is already present, so it will become n power 3. And then we will start multiplying like this. And remember that in alternate positions we change the sign, right? So what will be my integral? So this gives us that 1 over pi. Let us start multiplying now. So this gives me x square sine nx divided by n minus 2x cosine nx divided by n square, and as we discussed we have to change the sign, so this minus will become plus, and then we have minus 2 sine nx divided by n power 3 over the limits minus pi to plus pi. And if you see, first in all these three terms you will put x equal to pi. In that case, in the first term you will get sine n pi, that is 0. In the third term also you will get sine n pi, that is 0. And same thing when you will put x equal to minus pi in these three terms. When you put it in the first term, again it will become sine minus n pi, which is also 0. And in the third term when you put minus pi, it will become sine minus n pi, which is again 0. So you put pi or you put minus pi, in both cases this first term will become 0 and this third term will also become 0. So no need to write these terms in the next step. Here itself you can cancel them, because you know that okay, both these terms will become 0 for pi also and for minus pi also. So we have to bother only about our middle term. Okay, so let us put the limits here. If any constants are there, you can always shift them outside, like here 2 is a constant, so you can keep it outside the bracket. N square is also a constant, this also you can keep outside the bracket, right? So your term simplifies to 2 outside, so that will be 2, and n square outside, so that will be n square with a pi. Okay, and inside you are getting x cosine nx with limits minus pi to plus pi, and this will give me 2 by n square pi. First we will put x equal to pi, so that gives us pi cosine n pi. Okay, minus, now I will put x equal to minus pi, so this becomes minus pi cosine n times minus pi, so that will be minus n pi, right? And cosine minus n pi is same as cosine n pi, because we know that cosine minus theta is equal to cosine theta, right? We wrote this rule in the previous video also, but no problem. I will write it again. Cosine of minus theta is same as cosine theta. Okay. So finally we are getting 2 over n square pi cosine n pi, and here we will get minus will become plus pi, and cosine minus n pi is same as cosine n pi. So this gives us 2 over n square pi, and pi cos n pi plus pi cos n pi will become 2 times pi cosine n pi. And you can cancel this pi with this pi. So your answer is, I will write here itself, 2 times 2, 4 over n square cosine n pi. Cosine n pi is equal to minus 1 to the power n. So this is the value of your an. Now we have obtained the value of a naught, which is 2 pi square by 3, and we have obtained the value of an. Now we are in a position to write our Fourier series. So final answer, let us write. Therefore, the Fourier series is fx is equal to a naught divided by 2, which is our formula. A naught divided by 2. A naught value is 2 pi square over 3, which you have calculated already. So 2 pi square over 3, a naught divided by 2, right? This is the formula. Okay, plus summation an, which you have calculated just now, that is 4 by n square minus 1 power n, with a cosine n pi x divided by L, which is in this question equal to pi, and one more term which contains bn, but bn is equal to 0 because we are dealing with an even function. Okay, so no need to write that term. Okay, and this pi you can cancel here itself. So this is actually cosine nx. So this is your required Fourier series for the even function fx is equal to x square, defined on the interval minus pi to plus pi. Okay, so this is one question on Fourier series of an even function. So we have discussed both. In the previous one we discussed Fourier series of odd function, and today in this video we have discussed Fourier series of even function. Okay, so that's all for this video. We will meet very soon with another video on another topic. Okay, all the best. Take care, all of you.